Okay, hello everyone. So today we are going to start a new series of videos on steel bolted connection. Actually, we have very simple connection. We are going to use these plates, and this is the base plate and the angles, and then we are going to tie them together using bolted connection in Abaqus. These are the sketch and drawings of the connection that we have. This is the bolt. Probably we will not use the same design of the bolt in Abaqus. We will going to be make it more simplified because that's not gonna affect our connection. And here are some more details about the sketches, the dimensioning, and what will happen when it is under tension. And also this is without being in tension, and this is the full scale, which is for later. We will not model this for now. We will only model the connection itself, but probably this is the something, the model that is for the later stages. Yeah. So this is the upper arm front view. We have this one plate, and this is the cross section of this plate, and also we have the base plate where we have 4 holes for the bolts, and also we have 2 holes in the upper arm plate, and also this is the cross section of the base plate, and also we have the lower arm. So what we are going to do, we are going to connect the lower arm to the upper arm through the base plate by using angles. So that's what entirely we are focusing on. This should look like something like this. So let's start and get it done in Abaqus. Alright, so I have 2019 version, so which means that the files that I have in 2019 can be opened in 2020, 2021, 22, 23, and so on. And it might not open in older version, but I'm not quite sure about that. You have to try. Alright, so the first thing first is that we need to model each part separately, and then going to all the model steps that we have to do the modeling. If you haven't seen my previous videos, where I've explained all about those each step, how we can proceed with the modeling in Abaqus, what's the first step, what's the last step that we can do, what's all the important things that we need to keep in our mind. So all those things you can find in my previous videos in Abaqus. There is a video series for that. Probably one is regarding the beam column connection of the reinforced concrete sections. One of them is regarding the two-story brick masonry building. So I've done those, and it should be somewhere in my playlist. Alright, so just let's get started, and let's first model this part, the first plate. So all the dimensions that is mentioned here are in millimeters, and we are going to use the dimensioning in millimeters in Abaqus. So we have to be consistent in with our dimensions. So all what we can do is we are going to use Newton for the force, Newton, millimeter, and megapascal for the stresses. So if you're not familiar with that, you can just always use simple Google search or whatever you want, and just you can write Abaqus dimension units or Abaqus units, something like that. So the Abaqus has no unit, and you have to be consistent while using the unit. So if you just open any images, it's gonna show you how you can be consistent with the units. For example, if you're using SI unit in meters, you're going to use this, and if you use SI in millimeters, you're going to use these units. So probably we'll be using these units in millimeter, where we use length, Newton for force, ton for the mass density, which is ton per millimeter cube will in our case. Second for time, megapascal for the stress, which is newton per millimeter square, and joule just for the SI, and m joule for the in millimeters, and also for the density, as I mentioned previously, it should be 10 per millimeter cube. These are the dimensions that we're going to use. Okay, so let's get started. We have 126 by 5 and 50. So I'm gonna create a part. It should be upper plate. Name your parts and stuff properly so that it is easier for you to track it later. It is 3D deformable, solid, and extrusion, and I'm gonna draw it vertically. So it's around 550, so I'm gonna just have the approximate size of my gridding for 1000 millimeters. Alright, so what I can do, I can start anywhere at any point, and then we can do the dimensioning later on, considering the shape that I have, which is something like this. I can just start it, for example, from here. Oh, sorry, my bad. I need to select the lines first, because it will be easy for me to draw it through lines, although you can also use rectangular sections as well. So started from here, let's say all the way to here, and then here, if I'm not wrong, let me okay, yep, sure, and then let's go here, and then here, and then probably this line, and here, and then this line, and boom. Okay, so now we have randomly and roughly modeled the thing. Now we have to do the dimensioning. So the first, so this section is 300 meter and this is 250 millimeter. Sorry, not meter but millimeter. So I can just click this. It should be 300, and oh, it's always better to use for this section. Sometimes it happens because we have used the line segments, that's why it just popped up here. So it was 250, right? And now if I can choose 300 for this, it's gonna go upward instead of downwards. That's for the height. I have this dimension of 120 126 and 200 at the bottom. So this one is 200 and this one is 126. All right, so this section is 37 from both ends. So what I can do is, it is always a good idea to zoom things up to make sure that you're doing the dimensioning, all those stuff correctly. So this is 37 and it should be 37, which is, you can see, but I don't need to replicate it because it's gonna give me the error. It's called over dimensioning, so I'm gonna delete this. Done, it is already 37. All right, what else do I need? Yeah, for the moment I think I can just, I'm good. There are two holes here which I'll be doing later. I can even do it now, but the thing is that I want to do it later because I will be cutting an extrude section through this, and then it'll make thing easier. And also you will learn how to cut section if you have a section that is already built up, and how can you create different partitions or holes within that section. Alright, so done, and the, yep, it's done, and the thickness of the plate is 25 millimeters. So I've created one plate, that is the upper plate. Now let's just do the second plate creation and also the base plate, and then we can just create holes in all these three at specified dimensions. Alright, so yep, I'm done with this. The second is this plate, so it's just more or less the same, but it is inverted. So this is 240. Just remember, do not include, where did it go? Yep, do not include this 25 because that indicates the thickness of the base plate that will be placed over here. So we need to create the section from here, which is 240 mm and 190 mm and also 37 to everything is same. Just you can even copy that section and make it inverted, but anyways, I'm gonna create a new section, name it lower part. Yeah, more or less the same. I'm gonna take this thing, started from here all the way up to, just to be symmetric here, anything, just for example here, and then let's say just something like that, there, and boom, there you go. Alright, all I need to do is now to do the dimensioning, and the lower part I have is 190 and the upper part is 240. So this is 190. Oops, I should start with the upper part dimensioning because that's what I've drawn first. 240. Sometimes it happens, either view star is gonna pop up entirely in different direction against your expectation, but anyways, what can we do? We can just dimension the other part as well as 240, and then we can dimension this as 190 separately. Yep, so now even if you want, you can delete this dimension, but anyways, entirely up to you. As long as it didn't show up in pink, you are good. And this one was supposed to be 240 if I'm not wrong, right? Alright, 200, sorry, my bad. 200 and then 126, so that should be 200, and this is 126. Is that correct? Yes, 126. And also we have the same 37 mm at those locations, 37. And you need to check this. Oops, not the angle. I just pressed Ctrl Z so it reverted. So zoom in and check this. So it's always 37. If I press enter, it's gonna show me the ping. That's problematic. So it's just over dimensioning. The Abaqus won't go any further until you delete this thing, and done. Okay, more or less I'm almost done. Just click done, and then I have 25 mm thickness, and this is my second plate. Now I'm gonna come and draw the base plate. So the base plate that I have, it's just with more or less the same plate, but it does not have any of those sections, but the dimensioning are different, and it does have the hole, so we are going to take care of those holes later. Alright, so I'm gonna start with this 200 by 280. So base plate, probably 1000 is okay. I can even make, so now I can use rectangle, or even if you're comfortable with using lines, you can always use lines, but it's always easier if the shape is rectangle. And I'm not quite sure about dimension. 200 by 280. So this is 200, and this or this, both of them are symmetric, doesn't matter. It's 280 and it's done. The thickness of the base plate is also 25. Yep, 25 mm. Alright, so now what we're gonna do, we are going to create the section which is called those angles. We are going to create those angles, and also we will create the bolts. We have the dimension of the bolts here, and so the edge is 14.9 millimeter, and the head we have, it has a diameter of 35 mm, and also the nut, it has 14.9 mm, and yes. Alright, so we are not going to exactly replicate this bolt because it is not very important to model the bolt as it is, particularly in the current study. I'm not talking about general overall, because yes, it will alter depending upon your study, but here in this particular case, because we are going to use high strength bolts, we are not expecting any kind of failure in those bolts, so that's why it's not important for us to model a bolt like that, but without any threads and stuff. So we will be modeling is in a more simplified way. Alright, so let's just start with the angles and then we can come towards bolts. Alright, so let's just create these two parts, the angle and the bolt. First let's just create the angle. And just keep it the same, don't worry about that. Alright, so what I can do is just start it very randomly, like this, and there. Okay, so we have this dimension of 100 mm by 100 mm, and the thickness is 10 mm here and also 10 mm here. Alright, so the point is now we have to introduce a kind of groove here. We can also introduce groove here. It's very easy. We can use the fillet option here, which will create a fillet here, but I'm not gonna use this fillet option for here, which is mentioned in the section here, because it's not gonna impact my results too much, but this will definitely impact my result because it has a fillet section here, so that is important. Okay, alright, so dimensioning is now done. The next thing is to create fillet. So the first thing is, what's the radius of the fillet? I'm gonna keep it for now at 10. Press enter, select the first entity near the end to be filled. So this is my first entity and this is my second entity, and now it has created a fillet of round 10. You can also use the same for here, but I'm not going to use it. Like for example, I'm just going to show you how to do that. Yes, the radius is 10. Enter the first entity is, let's suppose this, and the second is this. Is going to create fillet weld here. So yeah, that's the thing. Just for the simplification, I'm using only here, but anyways I can also use it like this, but let's just use it like this. Anyways, it's not gonna be not gonna bring too much complication. It will bring probably some complication in meshing, but anyways it's okay. And also I can use fillet for here, but anyways let's just keep it as it is. And then yep, more or less it's done. And then the depth of this thing, because that's the cross-sectional view, so it will go all the way to the other portion. So it should be the equal to the depth of this let me show you here, as you can see. So the angle is something like this. It should goes all the way to the thickness of sorry, to the width of this beam. So in our case, because the base plate here is 280 by 200, but I'm not going to use exactly 200, because if you have take a look here, so the dimension from here to the bolt is 60 and this is 160. So probably I'll just take the 30 from here and 30 from here and 160 from here. So 160 and then 30, 190. So instead of 280 or sorry 200, I'm gonna use like 180. I'm gonna deduct the 2 from both sides, 20 mm and 20 mm. So let's just use it for now, and then we, if there was any problem, we can always adjust the dimension later. Alright, so it's 180 and okay, so that's our angle. As you can see, this is how the fillet is created. Okay, and the last thing is the bolt. I'm not going to model the exact same bolt with all those pitch and round things. All I can do is to model a simplified bolt. I have the dimension. The bolt diameter is how much should be? Yep, 25 mm. I'm gonna, so if the dimension is the 25 mm, it will make the radius of the bolt as 12.5 and turn, and the length of the bolt, excluding the head and the nut, only the length of this portion. As you can see, the length of this portion, you can all easily get the length with from the dimension of these two plates, the thickness of base plate and the thickness of our angle. So the base plate is 25 mm and the angle is 10 mm, so it will make it 35 mm. And alright, so now this is the inner portion, or whatever you call it. This is this portion. Let me show you. Where is that? Yep. So this is actually this portion from here. So it does not include the head and the nut. Now we're gonna model those head and nuts separately. Okay, so what can we do for that? We can use this option here, create a solid extrude, and select a plane for the solid extrusion. We can choose this plane and select an edge. So we can choose this edge. It will pop up this thing, and what I can do is to model the head, which is 35 mm in diameter. From here, let's just keep it so 35 divided by 2. What should be the, is it 17.5 if I'm not wrong, and 10. Okay. Alright, so now the thing is that the direction, you need to specify the direction. So direction is this direction in Z direction, which is correct. And how much do I need it? It should be the h, which is this dimension, which is the 14.9 mm. So it is 14.9 mm in this direction. And okay, so now it's the size, and I also need to create the same thing on the other side. So just I can repeat the process. I'm gonna rotate it, choose this, select the plane, and circle this, and then I can put dimension as 17.5, 10. So now it is, you have to make sure you can always rotate it. It won't delete your things if you choose any other option in the middle of something. For example, I choose this rotation option, so to make sure that the extrusion is in the correct direction. So I can always close this, and this window will pop up again. And the dimension is, I believe it's the same for the nut. It's also h, which is 14.9 mm, 14.9 mm extruded in this direction, and okay. Alright, so now I have the nut and bolt already set up. Alright, so that's all for this video. We have created all the paths. So in the next video, what we're gonna do is we will create the holes in all those plates that we have. For here we have 2 holes here, and we have some holes in my base plate. And we will do, because the holes need to be done properly, we have to calculate this particular point here. We have to calculate exactly the center of each hole, and based on that we can provide a hole within the base plate, and also the hole within the upper angle. So that will be the next step, and then we will go on with the rest of the step. Okay, so yeah, that's it. See you in the next video.